Hey, welcome back. Kind of a better way to do question 6B from the 2021 BC Calculus exam. So let's take a look at this one. Maybe it'll make it look a little bit better. In part A, we used the integral test to show that a series converges. In part B, they said use the limit comparison to show that this alternating series converges. And of course, they're saying use the original one that we already did. So we want to show that this series here converges absolutely. Now you might remember, to converge absolutely, we're basically saying that this series will converge regardless of the sign, whether it's positive or where it's all negative values. So I already know that this series will converge. It's an alternating series. I can even write that down. The series alternates, decreases in magnitude, and the limit equals 0. Therefore, I know that the series from n equals 0 to infinity, negative 1 to the n over 2e to the n plus 3, converges by the alternating series test. That's all you have to write. Okay, so I know this converges, and now I want to see, well, will this converge absolutely? Now, to converge absolutely, we want to check just the positive. In other words, we are wondering, will the series, as n goes from 0 to infinity, of 1 over 2e to the n, will this converge? Now again, normally I wouldn't use limit comparison. I mean, actually, I guess we've got to kind of use limit comparison here. So we're going to use limit comparison to do this. So what limit comparison says to do is I am going to, take the limit, take the limit as n goes to infinity of our function right here, 1 over 2e to the n plus 3, and I divide that by my b sub n. Remember, in limit comparison, this is my b sub n. So I'm going to divide that by it, and this becomes e to the n over 1. And I just want to make sure that this will become a finite number, therefore. So, and it does. As n goes to infinity, really the 3 doesn't matter much. What I'm really left with is just 1/2. And this is finite. Therefore, I know that the series, as we go from 0 to infinity, of the positives converges by limit comparison. So, my series will converge if it alternates. It also converges if we get rid of the signs, positive or negatives. If we just make them positive, or just all positive, or just all negative values right there. So, therefore, we can say that the series converges absolutely. And we're done. All right. I'll see you all later. Bye-bye.